this point, very quick recap. So we know how to do word embeddings because we show, well, in this presentation I show only 2 algorithms to do that, word2vec and fasttext in particular, and we saw how these embeddings, they expose very interesting properties that can definitely help the models. In particular, they're capturing some semantics associated to these words. But we did one more step. So we saw that it's not enough to have this mapping word to embeddings. We also want to consider the context. So we introduce Elmo. So Elmo is basically creating this contextualized view for the embeddings. And now we can use this to train our model. We can put Elmo between the input and our model. So are we done now? And actually, no, because there is yet another system. Actually, there are much more, but for this presentation, it's just one. And this system is called Bert. Bert means bidirectional encoder representation for transformers. And Bert has been a very important architecture. It really improves the results in many, many tasks. And probably it's your first choice to try if you have some NLP task that you want to solve, at least to get a very nice baseline. So the difference between Bert and Elmo, well, Bert is based on the transformer architecture. If you remember, Elmo was based on LSTM. And Bert, during the pre-training phase, doesn't use language modeling. It changed that task a little bit, and it introduces this task, which is called masked language modeling. We will see this in detail in the next slide. But actually, it also uses another task, which is called next sentence prediction. So let's take a look at these 2 tasks. So masked language modeling, it's very similar to language modeling. So we take a sequence, we mask some tokens. In this example, it's only 1, but you can mask more than 1. And you ask the model to predict the token back. It's very similar to language modeling, but there is no left to right or right to left. Like if you see here, I'm trying to predict this word in the middle, which should be lived. And the model is able to look at Alan Turing, which is the past, but also at the future, which is in England. So while in language modeling we have an order that we have to follow, and we can only look either at the past or at the future, masking language modeling is not like that. And on top of that, I can mask more tokens. Here is just 1, but I can have more than 1. So that's the first difference. The second difference was the second task is next sentence prediction. So basically here, we are giving 2 sentences to the model, and we are asking the models to tell me if the 2 sentences are contiguous or not. So you see that the first case is a contiguous one because someone went to the store and he bought milk. So most probably this is a contiguous text. Not the case in the second example. And this should help with the task that we have seen at the beginning of the presentation, where we have this task based on 2 sentences. Because here now the model is forced to capture a relationship between sentences. So the very cool thing about Bert is that with Elmo, we still needed to build our model. And Elmo was between the input and our model. But Bert, we don't need our model anymore. We can use directly Bert. So that's very convenient. So basically, Bert has been pre-trained by someone because it takes forever to pre-train. We can download Bert. We can choose the task that we are interested in, and now we can fine-tune. So we can keep training this model on the data that we have for our task, even if it's not too much data. And you see the difference here. Before we need to create another model, now we can use Bert directly. And in fact, there are the architecture of Bert will change slightly according to which task we are solving, but the cool idea is that the core part of Bert is already pre-trained in the pre-training phase and with a lot of data, because that was unsupervised. And here you can see 2 examples, so I will not go into details because we don't have too much time, but basically you see that the architecture will change mostly on the top just to accommodate the kind of output that we want to predict. But again, the core part stays the same. So some results. We'll not go into details. You can just see that Bert is doing better everywhere with respect to the previous approaches. In particular, there are two models. I think base is 12 layers, large is 24. So we're talking about very big models now here. And you see how Bert is really improving the results.